Can start. Good afternoon, everyone. My name is Francesco Longo. I'm from University of Calabria, and I'm really glad this afternoon to chair this session. The title of the session is Simulation as Decision Support Tool in Crossing-Cutting Industrial Sectors. Indeed, we do have 4 presentations this afternoon. They will talk about how we can use simulation, system dynamics, and even artificial intelligence in different sectors, from ship design to small and medium enterprise digitalization and supply chain and logistics. We will start with the first speaker, Marco Gianni, that is going to talk about system simulation as decision support tool in ship design. Gianni, the floor is yours. If you want, you can share your screen, and you have 15-18 minutes for presentation, okay?
Okay, perfect. Can you hear me?
Yes, now perfectly.
Okay, now I start sharing my screen. Okay.
Perfecto.
Perfect. So, good afternoon, everyone, and thank you for being here. I'm Marco Gianni, and today I'll present the work that I've done in collaboration with Alberto Marino and Vittorio Bucci, named System Simulation as Decision Support Tool in Ship Design. Ships have been used for thousands of years and are one of the oldest means of transportation. Shipping industry is facing many changes in these years. National and international organizations are trying to cut emissions from ships with mandatory regulations that limit quantities of greenhouse gases, sulfur oxides, nitrogen oxides, and other pollutants. International Maritime Organization, IMO, has delineated an initial strategy to reduce CO2 emission per transport work by at least 40% by 2030, pushing efforts towards a 70% reduction in 2050 compared to 2008 levels. There are 2 main ways in shipping industry to reduce emissions. The first option is switching from heavy fuel oil, that is the result of distillation and cracking process of petroleum, to more refined fuels. This allows implementing different power generators like dual fuel internal combustion engines or even fuel cells. Second option is to eliminate part of this pollutant directly from emission reduction systems, like selective catalytic reduction systems or scrubbers. Also, during past years, ship performances were improved by new production technologies like software simulation instruments, robotic welding systems, finite element methods, and also computational fluid dynamics. For this reason, a new approach to ship design is needed in order to address the challenge of implementing different and innovative technologies on board. Especially in early design stages, very important decisions must be taken without having detailed information about each system that will be inside the ship. So in order to support decision-making, simulation of different alternatives since early design stages is beneficial as allows conflict resolution. This study has been developed thanks to the collaboration between Fincantieri, that is an Italian ship designer and shipbuilder, and the University of Trieste. Fincantieri wants to offer to its customers vessels that meet emission requirements during whole ship life cycle. And in order to meet this goal, a multidisciplinary approach to ship design is required from early design stages. In this process, simulation tools are a fundamental part because they allow evaluation of ships when the design is already in its first phases. For this reason, so Fincantieri is working alongside the University of Trieste, and for example, when has funded the installation of hardware and software systems into the integrated ship design lab in Florence, Italy. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. So this is the case of the ship that is being built in Florence. ships. First of all, their business during the last years has been based on cruise ships of all market segments, from small luxury ships to very big contemporary cruises. Naval market segment has also a big importance for the company, since it's not only related to the Italian Navy, but also to other international partners. Also, thanks to Vard acquisition, Fincantieri has incremented its expertise in the offshore market segment. And the Italian company is also a supplier for various equipment services. In this a simulation tool to assess the overall impact of different energy generation system has been used to support decision-making in ship design. In order to preliminarily address how different power generators, technologies, influence the final design, a trade-off analysis has been carried out for 8 different layouts of power generation systems with respect to 6 different attributes. There will be an overview about current technologies and fuels that are adopted on board ships for power generation on board, and on some of the possible configuration for the future. The study will also highlight the main challenges to be considered when a new generation system is set up. So, the design process of merchant ship is composed by distinct and increasingly more definitive stages. So, concept, preliminary, and contract are performed before contract signing between the shipbuilder and the ship owner, future ship owner. And in these phases, a trade-off analysis is performed in order to find possible design compromise. In these phases, the ship is treated in its entirety, applying system engineering methodologies. Ships are systems interacting with each other, and 4 main systems can be identified. These are the hull, so the whole structure that needs to withstand internal and external loads. Platform systems, that are the systems that allow to sail the vessel and to control it. Mission systems, that are the system required for the ship's specific purpose, and all the outfit and furnishing. Systems and their subsystems interact with each other in multiple ways, and they all contribute to general aspects like capital expenditure, operating expenditure, payload capacity, and also safety of the project. So, first data input in the model, the ships operating gross tonnage of 150,000 gross registered tons have been taken as a reference case. We can say that approximately for a cruise ship like this one, passive user require about 15 megawatts, while propulsion at contractual speed need about 1. So, cruise ship dailies operating profile have been modeled 12 hours navigation and 12 hours moved import.
Gianni, we cannot hear you well.
In order to set the analysis, also we identify the 16 attributes, different attributes. Oh, okay. Well, I don't know. Sorry, something with connection.
Maybe there is some problem with connection. At least myself, I was not able to listen you very well. So maybe let's try again. Maybe there was a problem on your connection.
Okay. I will start again, or
No. Just let's try to go ahead and let's see if it works well or not.
Okay. Sorry.
Maybe you can switch the camera off.
Okay. So in that we comment, so because I need to stop sharing the screen. Okay.
You have to switch your camera off. I mean, okay.
Yes.
let's try to share the screen and let's see if it is better.
Okay. Perfect. Okay. So, as I was saying, we input data was the ship's operating profile, and also we identify attributes, different attributes to evaluate the ship's behavior and the ship design.
Gianni,
for attributes are.
We cannot see your screen. We cannot see your screen, and even the connection is still not so good. At least I feel I'm not the only one. I will ask to the other participants if they can tell us if the audio was good or not.
Hi, this is Sebastian. I had the same problems.
Thanks.
So how can maybe I will speak later? I don't know.
Let's try. Now I have just received your screen. Let's try just the last time. Otherwise, we can try again later.
Okay. Okay. So as I was saying, we identified 16 different attributes to evaluate the design of a ship, and the 9 attributes are related to how the new ship generation system influence the vessel characteristics. To describe how each alternative affects the ship emission, and 4 attributes are related to ship owner expectations and requests. Among alternative design considered, these are the current technologies available in the marine sector. The first application is one of the electric cruise ship power plant that consists of diesel and injectors. These engines burn HFO, that is heavy fuel oil, also identified as IFO 380, and this number is the cinematic viscosity. And this configuration emits great quantities of noxious emission. The second alternative is the same, but in the exhaust gas ducts, scrubbers are installed in order to comply with current emission regulations about sulfur oxides. Another option is replacing HFO with liquid phase fuels characterized by sulfur content, like low sulfur fuel oil or marine gas oil. And the other one is to use as marine fuel natural gas in dual fuel internal combustion engines. And this technology is a proven option to eliminate sulfur emissions and has also significant decrease in nitrogen oxides emission and particulate matter. Also, generation, the following alternatives have been considered. Methanol is an alcohol used mainly as a precursor to common chemicals, and it's liquid at ambient temperature and doesn't produce sulfur oxides emissions. Then another option for gaseous fuel utilization is the integration of fuel cells on board that are electrochemical devices that combine both engine benefits. For example, fuel cells characterized by high operating temperature and with lower emissions than dual fuel internal combustion engines, thanks also to their higher efficiency. Then there are also PEM fuel cells that can operate only with high purity hydrogen and is stored in the cryogenic tanks. Also, these benefits are balanced by some disadvantages, like the high capital cost of these technologies. Also, another option is batteries, but just as energy storage system and not to power loads for long periods of time. So, you the presentation is better now or not?
Little bit better. It's just a little bit better. Let's try to go ahead.
Okay, because this is the most important part about the simulation. So attributes considered are the rows in the decision matrix, and on the columns we have the different alternatives. According to input related to ship under analysis, the simulation tool determines for each alternative how it performs about each attribute. It calculates, for example, the size of reactors, the size of fuel tanks, and the total ship emission. Then, knowing this data, the impact on auxiliary systems like ventilation, fire safety, heat recovery, fuel management, and also electrical distribution system can be determined. And also in this phase, CAPEX, OPEX, and payload capacity are calculated. Then the tool is able also to evaluate full structure modification, ship stability changes, and the safety perceived by passengers. So the decision matrix has been filled with scores using a 10-level scale, where higher values means a better performance for the associated attribute. This can be considered as an initial estimation of the real attribute's value, since the calculations are performed during initial design phases. For example, considering nitrogen oxide emissions, each solution, this means that each alternative emits the same or less nitrous oxides. And another example is, for example, the size of the storage system, and as you can see, HFO and low sulfur fuel oil are the smallest. Then, after the decision matrix has been filled, TOPSIS method has been used to determine a ranking for the alternatives under evaluation. Each element of the matrix has been first normalized, and then 3 different weight sets have been established, and so each element has been multiplied by its associated weight. Weights allow distinguishing 3 cases, where the first case is when we give equal importance to owner requirements and emissions, describing a future in which owner will require ships compliant with emission regulations. Then the second case is where emissions have the highest importance, and the third one is more or less the opposite of the first one. At this point, ideal and anti-ideal solution have been determined as the collection of the best and worst values of the attributes. And then the separation distance from ideal and anti-ideal solutions has been calculated for each alternative by the 2-dimensional Euclidean distance. And finally, we determined the degree of closeness. Closeness range from 0 to 1, and a higher value corresponds to a better alternative. So, as you can see, here we have the final rankings. When analyzing the case in which owner requirements are have equal importance to emissions, 3 preferred alternatives are LNG dual fuel internal combustion engines, low sulfur fuel oil and marine gas oil, and also HFO. This is because these alternatives have a relatively low or neutral impact on design, but also a very beneficial impact, especially the first 2, on emissions. And alternatives with greater beneficial impacts on emissions have, at the current state of the art, a very negative impact and are highly penalized, like PEM fuel cells and batteries. When maximum importance is assigned to emission reduction, LNG dual fuel internal combustion engines and solid oxide fuel cells are among the preferred option, alongside with methanol and also PEM fuel cells. Natural gas, in fact, is a proven good option because it doesn't affect heavily payload capacity and has a competitive price, both in terms of CAPEX and OPEX. When functional design impact is considered the most important aspect, so the functional design point of view, well-known solutions for power generation have the highest rankings, like low sulfur fuel oil, heavy fuel oil, and also heavy fuel oil and scrubbers. So I jump to conclusions, and as we can see, as we have seen, I hope that you have seen something. In these years, ships are undergoing a lot of changes. In particular, new requests from ship owners and the regulators are influencing the generative power plant, and inevitably the entire ship design. To address these new requests, a system thinking approach must be adopted since early stage design. In the cruise ship taken as a reference case, a decision matrix has been set up to evaluate how 8 different alternative power generative solutions perform regarding 16 different attributes. And system simulation has been performed in order to fill out the scores of the decision matrix. And since decision matrix is sensitive to weight factor, 3 different sets of importance have been assigned to attributes in order to compare results. To rank the alternatives, top systematic resulted the most desirable because they had the highest degree of closeness to ideal solutions. And when functional design impact is given maximum importance, low sulfur marine bunker fuels and scrubbers reach the highest standings. And so attractiveness of each solution now in the future will depend highly on ship operative profile, vessels type, and also on new emissions limitation and taxes. Thank you for your attention, and sorry for all the problems.
Thanks, Marco. Thanks a lot. Questions? If you have questions, you can raise your hand. I have just one small question.
Yes.
You mentioned in your presentation, one of the last step of your presentation, there was a flowchart. In the flowchart, there was one of the piece was stakeholder satisfaction. So yes. In this case, I was just wondering if the approach that you have developed has already been applied to some real cases and to some real ship that is now under construction or under delivery to the final customer, or it is still in the research phase and you plan to apply it in the future?
Well, right now stakeholders are just internal to our company because these are just research and development projects, but we are planning to explain and also to propose these possible solutions to ship owners. Surely the pandemic situation has a negative impact on the research and development project, and also to the possible interest that ship owners and clients can have about our new solutions, because they all imply the willingness to invest some money and to try different technologies. And also, so for now it's just about our stakeholders internally, but we plan to have to have more stakeholders involved, also from different companies and from different points of view, not just from our point of view of the company. Yes.
Sure, sure. There is another question from Professor Diaz. Rafael, please.
Yes, thank you, Gianni, for the presentation. I'm sorry that you have some technical issues because it was very interesting.
Sorry.
That's okay. You know, like I kind of follow the part that uses simulation for chip design. And my question is about scenarios and optimization, because you use simulation to test different measure of performance, but at the same time, do you have like in your simulation or in your vision of your product some type of way to explore or do sensitivity analysis according to an optimization algorithm behind? In other words, you know, this, you know, for example, some suppliers may be late or something like that, and then in that regard, you maybe have some options to optimize or keep working without coming some more delays. So do you are you using that data to do some kind of forecasting or using some resource allocation? That's my question.
Okay, these are just no, as you said, these are some of the future development that we work will have. But one of the main thing is that optimization, to apply optimization to the whole ship design and to the whole ship as a unicum and just one object is very, very difficult to apply. Apply optimization to the whole ship. It's better in this case, and we and also my colleagues have applied it to maybe smaller systems inside the ship. To apply to the ship as a whole system, it's very, very difficult, the optimization. But forecasting algorithm are something that we are trying to apply also to these works. And some of them are already applied because, for example, to forecast how much quantity of all the consumables for the ship propulsion plant and generative plant, and also to forecast how much and all other things that are needed for the ship design. All of that are also done applying some of these algorithms. Yes.
All right, gracias. Call me.
Okay.
when you go to that place to connect on that, because that's part of my research area. Thank you.
Okay. Thank you.
We move now to the third presentation. Okay. So the third presentation will be given by Sebastian Lang, that is going to talk about open source discrete event simulation software for application in production and logistics, an alternative to commercial tools.
Yes, hello from my side. One moment, I share my screen.
Yeah.
I think this is the screen which you need. So can you see it?
Yes, perfectly.
All right, then let's go. So hello from my side. My name is Sebastian. I'm happy that you attend to my presentation. Before we start, let's take a short look on the outline. So first I will start with some motivation slides. The second and the third point is then actually what we have done. So what is the paper about? And the last slide is dedicated to the conclusions. And all right, let's start. So our motivation. So to explain our motivation, I will start with a little question. Why is it necessary or worthwhile to care about open source discrete event simulation? Because considering that there are already many commercial discrete event tools on the market, I think everyone here in the audience is an expert in simulation. So most tools which I present here, Arena, AnyLogic, Flexim, should be a term for everyone. And as everybody of you knows, those tools are all designed to create discrete event simulation models, but they are in particularity, they are slightly different, provide slightly different features. And that is good on the one hand, because depending on the problem or depending on the field in which you do your research or in which you have your company, it is always good to have a simulation tool which is tailored to your needs. But considering now you are a small or medium-sized company, then you have a big problem. Those tools are often very expensive, and I don't know the price for all the simulation tools, but it is, I know it for Technomatics plant simulation with $60,000 approximately. So for Arena, AnyLogic. So you have to pay a high price to dive into discrete event simulation. And if we now consider the first point, so let's think about a small or medium-sized company which is interested in discrete event simulation. So first, they have to do affordable market research. They have to analyze the different tools. Maybe they don't have an idea about discrete event simulations. They see the different features, and then they have to do it because those tools are very expensive. In our opinion, and also according to our experience, this is often an obstacle for small and medium-sized companies to work with discrete event simulation. And this is also a problem for universities, because a lot of those tools are offering, of course, study licenses and educational licenses, but those licenses are often very limited for research. So that is the third point about we think it is worthwhile to take a look on open source tools. All the tools which you see here are closed platforms and they are difficult to extend. So I think every one of you noticed, so we saw it also in one of the presentations, since 2 years or so, a lot of research institutes and universities started again to do research in machine learning, in particular to combine machine learning with discrete event simulation for solving planning and control tasks in production and logistics. And maybe also somebody of you is doing his research in this field. I do it. And when I started, I got to know that it is quite difficult to use these commercial tools because they are closed. The machine learning frameworks are usually written in Python, and it is not so straightforward to connect one of those commercial tools with Python libraries like TensorFlow and or PyTorch. So I know, for instance, tools like plant simulation are offering connectivity interfaces, but that are not they are not included in the educational version or even not in the professional version. You have to pay around 10,000 euro in addition to get these capabilities. And the last point, this is actually for beginners, so for people who are not into discrete event simulation. Those tools are often complex and therefore hard to approach. So I remember when I wrote my bachelor thesis, I started with discrete event simulation and I started with Extensim. And I thought, okay, let's take a look in the manual. So it will explain all the necessary details. And then I was a little bit shocked when I saw that this manual has 1,363 pages. And so that was quite demotivating, but nevertheless, I did it. And another point is, if we take a look, for instance, on plant simulation. So I had to talk with a professor from another institute. He's not into discrete event simulation, but he had somebody from the industry who wanted to solve a little problem. And first he started to model this problem in plant simulation. It required maybe 3 processes, a sink and a source. But then he said, okay, plant simulation is too overweighted. It is too difficult to dive in. And he used an open source tool, in particular Salab in the Python library. And if we take a look, for instance, here on the sink element, every one of you knows a sink is actually, or the function of a sink in a material flow simulation is that it destroys the objects which are not anymore necessary in the simulation. But already for this sink, we have very, very many options. So different tabs, different configuration possibilities. And that is only one indicator which you can see, that it might be not so easy for beginners to work with these tools and to learn those tools. So that are the reasons why we started to do our work with open source tools. And at the beginning, that was 2 years ago, we started to do some research, maybe to get a first idea which tools are worthwhile to investigate. And we got to know that there is as good as no research concerning open source tools. In fact, we were only able in that time to investigate one paper. It is from Takakis and Heavy, researchers from Ireland. And the paper is a review of open source discrete event simulation software for operations research. In my opinion, a very good article. It was published 2016 in the Journal of Simulation. And this paper provides a really encompassing overview about open source tools. I think they compare more than 30 simulation libraries, however, in a very aggregated and quantitative manner. So actually, when we did our investigations, we were interested in some user experiments. So how does it feel to work with these libraries? How is the modeling process? How is the usability? And we couldn't find any experience reports. And that was actually the motivation after 2 years to conduct a little comparative study and to evaluate these tools from a more qualitative point of view. So, and that is actually the goal of this paper, to give an exemplary comparison of open source discrete event simulation tools with commercial tools in terms of usability, features, and utility. Okay, so as I said, we did a little study, and the first step was to select some tools. So from the commercial side, that was quite easy. We decided for Arena because according to a WinterSim article, Arena is still the most frequently used discrete event simulation software worldwide. And then we also decided for Technomatics plant simulation because not only because we are used to it, but it is also, I think, in Germany, the most famous tool, especially because it's the standard tool in the German automotive industry. Yeah, because of an add-on which is developed by the Association of German Industry Engineers for automotive applications. And on the open source side, we decided for Salabim. It's a Python-based library. So our decision were driven by the fact that we wanted to start to combine machine learning with discrete event simulation. So the decision was quite clear or obvious that we wanted to take one Python-based library. So there's also SymPy, which is pretty famous in Python, but we decided for Salabim because it is strongly related to the pretty famous Simula language. So that was the first simulation and also object-oriented language. And a lot of languages which came thereafter, for instance, GPSSH or SLX, took the ideas of Simula. So then we also decided for Jarmsyn. It's a Java-based tool, and it's, to the best of our knowledge, the only open source tool with a graphical user interface and with drag and drop modeling capabilities. So quite comparable to the commercial tools. And then we also decided for CloudSim, which is also Java-based, and which appears to be a quite odd decision because CloudSim is actually a discrete event simulator for cloud computing applications. So our decision here is justified by the fact that compared to the other open source tools, CloudSim is very often cited in the research community. So you can find more than 1,000 publications which cite CloudSim or which claim to use CloudSim. And this is really a huge particularity because a lot of open source tools, you can maybe find 2 or 3 papers which report some that they used it for their problems. So, and we designed a quite simple use case. However, this use case contains a lot of features and a lot of characteristics which we often implement in our daily work when we work with discrete event simulation. So this is a small 3-level manufacturing system, and we have here a stochastic inter-arrival times. We consider different product types, and we consider also stochastic processing times and different probability distributions. So here a normal, and in the third stage, triangular. Then we have parallel machines with different setup times and sequence-dependent setups. And setup times, pardon. And we have also product type specific processes. So for product A, the upper process, and for product B, the process down below. And those processes are sharing one mobile resource that it could be, for instance, a worker for assembly tasks. Yeah, and I think I have to hurry a little bit because now we have the slides about the different tools. So I think the commercial tools are not so interesting. So I will do them in one arena. Both have in common that you do the modeling in a drag and drop based manner. So with graphical elements. In Arena, it is related to block charts, in particular business process modeling. And in plant simulation, it is more the case that the elements are related to real manufacturing resources as machines and so on. And the difference is here the modeling objects in Arena are quite simple. So they don't have much attributes and configuration possibilities. And in fact, it is like that you model the system structure, so the material flow and the information within one model. So, and that has, in our opinion, huge drawbacks because the graphical representation of the model can become very large and confusing because you combine both information and material flow in one chart. And the debugging is also quite complicated because it is mainly based on model animation. In most Arena versions, scripting is not possible. So in the free version and also in the cheapest commercial version, I know there's also a version where you have a scripting language, but according to our opinion, university which use Arena do not have this license and are writing their control logics or are implementing the control logics with this block charts. So, and in plant simulation, so there are indeed possibilities for scripting of control logics. However, it is quite difficult to dive into those tools. It's quite complex, so you have a lot of options, and some aspects, for instance, shared resources here are quite difficult and cumbersome to model. So you only do not need the processes, you also need a resource pool, a second block element, and a broker, a third block element, and you have to do some configurations. And in our opinion, it could be also easier to implement this. So now we come to the open source tool. So the first tool is Salabim. So I was responsible to build the model in Salabim. You have in Salabim no graphical user interface, and everything what you model is written by code. And for me, it was quite intuitive thanks to the orientation on the Simula language. However, I have to admit, I have now since 2014 experience in discrete event simulation, and I'm quite familiar with coding. So I could imagine for somebody who is pretty new and who do not have so much experience, it is quite more complicated to dive into. With the help of the documentation, so there are a lot of examples, I required something around 6 hours to model the process logic and to get the first model which runs correctly. So quite short time. My colleague who is not familiar with Arena and also started with Arena for the first time required also something about 6 hours. And Salabim also provides a rudimentary animation framework, so which allows to develop custom model animations. So this is actually an animation which I implemented. And compared to the model logic, the implementation effort here was quite high. So as I said, 6 hours for the model logic, but for the animation, I required something about 1 week, in order that everything runs properly. So then our second tool is Jamson. So Tobias Reckelin, who is also in the audience, built the Jamson model. And JAMSIM was in fact pretty convincing because, as I said, it supports drag and drop based modeling, and it also supports the implementation of custom control logics, however, not with a scripting language, but with expressions in a separate input editor, which you can see here. So according to our experience, that was not so intuitive, and it could be difficult if you have more complex modeling controls to implement. JAMSIM has a really large PDF documentation, a separate user documentation, and a separate programming documentation to extend the capabilities of JAMSIM. And it provides also a mouse over help, which is also pretty impressive for an open source tool. And it has, of course, the best animation capabilities compared to all other open source tools. I think it is even possible to implement 3D animation with not so much effort. The last tool is CloudSim, which we compared. So it also doesn't have a graphical user interface. So modeling is based on writing code. And we faced a lot of problems with CloudSim. Yeah, we have known that CloudSim was tailored or is tailored for cloud computing applications. However, we thought, since it is also discrete event simulation, it is not such a big difference, yeah, to model instead manufacturing processes. However, we were wrong because due to the strong focus on cloud computing, jobs were only considered to run on one resource before leaving the system. And thus it was necessary to make fundamental changes to the pre-implemented classes. And yeah, that requires a lot of knowledge in object-oriented programming, and it's definitely not recommended for small or medium-sized companies, even not for students who study, for instance, industrial engineering. A pro point for CloudSim is the large documentation. So, and this is actually, that are actually our results as a table. I don't want to say something about the results because I would recommend that you take a look on the paper and maybe study the table there in detail. So then let's come to the conclusions. As you can see, the case study could be implemented with all compared tools. For some tools, it required more effort than for other tools. So in fact, for CloudSim, it required a lot of effort, and in SalaBIM, it depends how experienced you are in coding. So in our opinion, JAMSIM seems to be the best open source alternative for a typical industrial engineer. And maybe as outlook, we currently plan to integrate JAMSIM into curriculum of our master module as a separate block for open source discrete event tools. And SalaBIM is, in our opinion, the best open source alternative for researchers. I actually heavily use SalaBIM for my research, and I use it nowadays more often than our industrial tools. And right now, maybe as outlook, we apply for a research proposal in which we want to build a hybrid simulator, which combines discrete event and soft sensor simulation based on SalaBIM, Unity, and Gazebo. The idea is to have a holistic framework to generate synthetic data for AI applications. And CloudSim is not appropriate for, at least for production and logistics researchers or for companies in this field. So that was my presentation. Thanks for your attention. And if you have questions, go on.
Thanks a lot, Sebastian. We have, I feel, just 1 minute for at least one question. If you have question, please raise your hand. Sebastian, I have just a very quick question regarding the way to provide the simulation model to the final customer. I mean, you know that some of the software, they do not provide the executable file, the .exe file, as for instance, any logic only in the professional version, maybe plant simulation. At the time when I was using plant simulation several years ago, they were not providing the exe file and so on. So which could be the best solution for the final customer in order to avoid license cost on the final customer?
I think JAMSIM, because the whole JAMSIM framework has only a size of some kilobytes. So it is really small, and you can easily transport it or can send it via email, and maybe you can build a custom script which opens JAMSIM and the model and run experiments. So probably Salabim could be also an option, but according to our experience, it is quite difficult to set up a clean Python environment on a Windows computer. So that could be maybe a problem for some people in small and medium-sized companies. So I would go with JAMSIM in that case.
Okay, thanks a lot. Okay, it seems that there are no questions. So if there are no questions, we are going to close this session. Okay, thanks a lot, Raphael, for your very interesting presentation. Thanks everyone for joining the session. We have now a small virtual coffee break. We will see each other again at 4 p.m. Central European time, obviously, for the other session. Thanks a lot.
Bye-bye, Francesco. Bye to everyone.
Bye, everyone. Thank you.
Bye-bye. See you later, Francesco. Bye-bye.
Thank you, everyone. Bye-bye.
Bye.